This is the fifth video for Chapter 6 on trigonometric functions. And in this video, we're just going to look at inverse trig functions. Now, you've already come across inverse functions in the functions chapter, which was Chapter 2. So we're going to talk about inverse trig functions. Right, now, the standard trig functions, so y equals sine x, its inverse is y equals sine to the minus 1. You know, you've seen that already. You've seen that whenever you're solving sine equations. But if you see that written down in an exam paper, you won't see it written like that. You'll see it written in this form, arc sine x. So they put the prefix arc on it to tell you it's a inverse. Same with cos. The inverse is cos to the minus 1 of x. But again, if you see it written down, you'll see it as arc cos of x. And y, the inverse of tan, of course, is tan to the minus 1 of x. But again, if you see it written down, you will see arc tan of x. So, if these are our trig functions, f of x, these two forms are our inverse functions. Now, as with all functions, a function can't have an inverse unless it is one-to-one. And just because these are trig functions, they still obey the rules of functions. So, we need to restrict the domain of the trig function in order to be able to get an inverse. And we want the best or the nicest possible domain, but we want the biggest possible domain for it to be one-to-one. So we'll start by thinking about sine. So I'm going to just draw a quick sine wave here. And you can see there's a standard sine wave. But if I take the sine wave from the minimum on the left-hand side of the y-axis to the maximum on the right-hand side, and just pick that part of the wave, so we're going from negative pi over 2 to pi over 2, or negative 90, I get a one-to-one function. So the restriction for sine is negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. So that's the domain I'm going to pick. Of course, we can do it in degrees as well. So negative 90 to 90. Cos, not going to draw it, but we go from the maximum, which occurs on the y-axis, so that's when x equals 0, to the minimum, and that's when x equals pi, and of course that's 0, less than or equal to x, which is less than or equal to 180. Now for tan, we take the middle part of the tan graph. So you know you've got vertical asymptotes at pi over 2. So my restriction is pi over 2 is less than x, which is less than pi over 2. Or negative 90 is less than x, which is less than 90. Of course, because we've got vertical asymptotes, we can't have to have those values. Now we can use the properties of functions and their inverses to help us to draw these three new graphs, and you need to learn them. So I'm going to start with sine x. And you can see I'm going to start with the domain. The domain for the restricted sine x graph is negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. And the domain is negative 1 is less than or equal to y, which is less than or equal to 1. And remember, when you do an inverse, the range and domain values swap over. Okay, so the domain for the arc sine graph will be negative 1 is less than or equal to x. Remember, domain is always what's on the x-axis, less than or equal to 1. And the range will be negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2. Now, when we draw it, it's a good idea, if you remember, the coordinates swap round. So I'm going to pick three coordinates. I'm going to pick the minimum, the origin, and the maximum. And I'm going to swap those coordinates around. So the domain, the minimum was the coordinate negative pi over 2, negative 1. So that becomes negative 1, negative pi over 2. The origin, of course, 0, 0 stays a 0, 0. And the maximum coordinate was pi over 2, 1, which becomes 1 pi over 2. And the other thing is, remember that the inverse is a reflection of the original in the line y equals x, so the curvature changes. So anything that was concave becomes convex, and anything that was convex becomes concave. So that is our graph. We're going to use the same principle to help us draw arc cos. So I'm going to start with the domain and range. The domain, of course, is 0 is less than or equal to x, which is less than or equal to pi. And the range is negative 1 is less than or equal to y, which is less than or equal to 1. And again, they swap over. So the domain for the arc cos graph will be negative 1 is less than or equal to x, which is less than or equal to 1. And the range is 0 is less than or equal to y, which is less than or equal to pi. Again, I'm going to pick some coordinates, and I'm going to pick the maximum where this cos wave crosses the x-axis and the minimum. We'll swap those over. So the coordinate 0, 1 becomes the coordinate 1, 0. Coordinate pi over 2, 0 becomes 0 pi over 2. And the coordinate pi negative 1 becomes the coordinate negative 1 pi. And again, the curvature changes. So when I draw it, it looks something like this. Now, for the arctan, again, same thing occurs. Okay, so the domain is negative pi over 2 is less than x, which is less than pi over 2. And the range is y belongs to all real values. So again, they'll swap over. So x will belong to all real values, and the range will be negative pi over 2 is less than y, which is less than pi over 2. Now, remember, for the tan graph, and I'll do it in green, we have a vertical asymptote at pi over 2 and a vertical asymptote at negative pi over 2. So vertical asymptotes become horizontal asymptotes. Okay, so there's a nice horizontal asymptote at pi over 2 and another one at negative pi over 2. Now to help me draw it, I can pick 3 coordinates. We've got the origin, we've got the coordinate pi over 4, 1, and the coordinate negative pi over 4, negative 1. I'm going to swap those over, so I get the coordinate 1, pi over 4, the origin, and negative 1, negative pi over 4. And again, the curvature changes. So the graph looks a bit like this when it comes down. It comes down through those points and then finishes down here. And of course, it gets closer and closer to the asymptote as x tends to positive and negative infinity. So that's how we draw those. Of course, if we can sketch curves, we can also transform curves. And if you look, we've got 2 here to do. Right. The first one is arc sine of x plus 1, which is a translation of plus 1 in the y direction. So any x values stay the same, any y values we add 1 to. So we're going to start with the domain. And remember, because we are translating in the y direction, the x's don't change. So we're going to have a domain of negative 1 less than or equal to x less than or equal to 1. But the range, we will add 1 to it. So the range becomes negative pi over 2 plus 1 is less than or equal to y, which is less than or equal to pi over 2 plus 1. So I'm going to draw that now. So my domain, negative 1, 0, 1. Of course, it's going to cross here at 1. This is pi over 2 plus 1, and down here is negative pi over 2 plus 1, and I'm going to have my points. Again, it's just same shape as arc sine, and it looks a bit like that. Okay. Now the next one, B, is f of x equals 2 arc cos of x plus 1, and that is a translation of -1 in the x direction, or -1 in the x direction, followed by a stretch of scale factor 2. So, if you think, domain that was at -1 to 1 will go from -2 to 0, and the range that for arc cos was 0 to pi will become 0 is less than or equal to, be careful, it's f of x, which is less than or equal to 2 pi. So I'm going to mark those on my graph. This is -2, -1, 0, having this is pi, and this is 2 pi, and I'm going to draw my graph. So I'll put my 3 points on. Of course, it's the arc cos, which comes down like that. Right, now let's look at some questions where we are using our inverse functions and trig functions. So this first one says, given that arc cos x equals pi over 3. So I've got arc cos of x equals pi over 3. Now I want to get x on its own. So what I'm going to do is I'm going to take cos of both sides. So if I take cos of both sides, okay, this is what we do, take cos of both sides. It's not multiplying both sides by cos, it's take cos of both sides. Cos of arc cos, they cancel each other out, and you are left with x. X equals cos of pi over 3, and of course the cos of pi over 3 is a half. Now the reason that cos and arc cos cancel each other out, if you remember back to the work we did on functions, if I say that f of x equals cos x, f to the -1 of x therefore is arc cos x. If I do a composite function, the composite function I want is f to the -1 of x, that will be cos of arc cos of x. And if you remember from our work on functions, f to the -1 of x is x. So in other words, cos arc cos of x. So that's equals x. So they cancel each other out. X equals x. And that's the reason it works. So look at the next one. It says, given 6 arc tan x minus pi equals 0, find x. I'm going to rearrange it to get the arc tan x on its own. So I've added pi and divided by 6. So this time I'm going to take the tan of both sides. Tan of pi over 6. And therefore tan of arc tan is just x. Tan of pi over 6, and the tan of pi over 6 is √3 over 3. Just do one more of these. So it says, given that arc sine of x is negative pi over 2, find x. So again, we've got arc sine of x equals negative pi over 2. I'm going to take the sine of both sides. Sine of negative pi over 2. So the sine and arc sine cancel each other out, leaving just the x. And of course, the sine of negative pi over 2 is -1. Okay. Now we're going to look at some quite complicated questions that involve using these inverse trig functions. Now the first one says, given that y equals arc cos x, and you're given the range and domain, express arc sine x in terms of y, and hence evaluate arc cos x plus arc sine y, giving your answer in terms of pi. So I'm going to start with arc sine x. So I'm going to say let y equals arc cos of x. That's what I was given up here. Now, the first thing I'm going to do is I'm going to cos both sides. So if I cos both sides, I'm not going to write it now. If I cos and arc cos, I'm just left with x. Okay. Now, what I need to remember is the link between cos and sine, because I want arc sine. Now remember, cos is complementary sine. Therefore, okay, sine of pi over 2 minus y is the same as cos of y. That equals x. If I then arc sine both sides, and I'll actually physically write that down. So arc sine, the sine of pi over 2 minus y equals arc sine of x. Then the arc sine and sine cancel each other out, and then you get, therefore, arc sine of x equals pi over 2 minus y. Now part B says, hence evaluate arc cos x plus arc sine x. So arc cos of x plus arc sine of x. Well, arc cos of x is y. Arc sine of x we've just found is pi over 2 minus y, and therefore that is pi over 2. Again, quite complicated, that, especially if you didn't remember the link between sine and cos. The question 2 says, prove that for 0 being less than or equal to x being less or equal to 1, arc cos x equals arc sine of the square root of 1 minus x squared. Okay, so we're going to start with let y equal arc cos of x. Okay, and of course if 0 is between, x is between 0 and 1, then y must be between 0 and pi over 2, according to the arc cos wave, if you remember your arc cos wave. Right, if I cos both sides, I'm going to get cos of y equals x. And therefore, x squared will equal cos squared y. Now, why have I done that? Well, I'm going to remember another trig identity that I already know. I know that sine squared y plus cos squared y equals 1. I rearrange that, of course, I get sine squared y plus, if I replace cos squared y by x squared, I get x squared equals 1. So sine squared y equals 1 minus x squared. All I've done is replace cos squared y by x squared. Then, of course, I need to square root. And when we square root, we get 2 answers. Now you can see I've now got the square root of 1 minus x squared. I've got to explain why I'm going to just take the positive 1. Now we knew, and I'll just put it in a bubble box, that y was between 0 and pi over 2. And if you think sine y, think about your sine wave, between 0 and pi over 2, sine is positive. So I'm going to write that down. Okay, so between 0 less than pi over 2, sine y is positive. Therefore, I take the positive square root. Therefore, sine y equals the square root, positive square root of 1 minus x squared. So if I then arc sine both sides, and I'm just going to up here, if I arc sine both sides, arc sine of y is y, and I need to arc sine the right hand side, which means I get that. So I've got the other side. Okay. So I've got from one side to the other side. I've got from the left hand side, remember, this was the left hand side, and I've now got to the right hand side. Now it says, give a reason why this result is not true for -1 being less than or equal to x being less than or equal to 0. So let's write out the reason why. So if -1 is less than or equal to x, which is less than or equal to 0, arc cos of x is between, so pi over 2 will be less than or equal to y, which will be less than or equal to pi. Think about your arc cos wave. You can look back and see what it looks like, right? But arc sine, its range, okay, is minus pi over 2 to 0. So again, that's not true. Okay, but the arc sine's range is minus pi over 2. And of course, if we wanted them to be the same, they need to have the same range. Now we'll have a little look at this last question. It says, given that x satisfies arc sine x equals k, where 0 is less than k, which is less than pi over 2, state the range of possible values of x. Now the first thing I'm going to do is over here, I'm just going to draw the arc sine graph. Now if you remember, the arc sine graph looks like this. And it goes from -1 to 1. And again, so if k is between 0 and pi over 2, it's here. Because if you think, k is actually the y values. So that corresponds to these x values, the ones I've just coloured in red, and therefore that must be 0 is less than x, which is less than 1. It then says, express in terms of x cos k. Right, now if you remember, I'm going to do something similar to what we did before. So, cos squared k plus sine squared k equals 1. If I rearrange that, I get cos k equals plus or minus the square root of 1 minus sine squared k. We were told at the beginning that arc sine of x equaled k. If I sine both sides, I get x equals sine of k. Therefore, x squared equals sine squared of k. Therefore, I can substitute that back in there, and I get cos of k equals plus or minus the square root of 1 minus x squared. But of course, because k, we were told at the top, k is between 0 and pi over 2, then cos of k will be positive. Okay, we can write that as 0 is less than k, which is less than pi over 2. You know, for your cos graph, that will be above the x-axis. Therefore, cos k is positive. Therefore, my expression is 1 the square root of 1 minus x squared. Now tan of k, of course, is sine of k over cos of k. Well, we know that sine of k, we've got it up here, I'll just highlight it, is here. So that's x, and cos of k, we know, is the positive square root of 1 minus x squared. The last bit says, given instead that negative pi over 2 is less than k, which is less than 0, how, if at all, would it affect your answers to be? So, if minus pi over 2 is less than k, it's less than 0, we had cos of k. Cos of k would still be positive. You think of your cos graph from minus pi over 2 to 0, it's above the x-axis, so it's still positive. Therefore, cos k equals the positive square root of 1 minus x squared. There will be no change. Okay. And again, if minus pi over 2 is less than k, which is less than 0, okay, that tells me, if you think about your arc sine graph, that tells me that minus 1 is less than x, which is less than 0. In other words, my x value is negative. Okay. Sine k is negative, because between the values of minus pi over 2 and 0 for k, sine k is negative. Think about the graph. Therefore, this is still true. X is a value between negative 1 and 0. So in other words, sine k will still equal 0 because, still equal x, because x is between negative 1 and 0. So there is no change to x over square root of 1 minus x squared. We don't have to put negatives in front of it. Again, think about it. And that's the end of the video for chapter 6.